AD square, side, one side square plus the other side square. Sum of the squares of two sides which is equal to square of hypotenuse, which is nothing but the Pythagoras theorem. So R is equal to root of A square plus B square plus 2AB cos theta. So the cos 90 value is 0. So the component is resolved into two parts, along x-axis, along y-axis. So along x-axis the magnitude is represented as A cos theta, along y-axis the magnitude is represented by A sin theta. Hello everyone, welcome to session 2 of chapter 4, Motion in a Plane. This is Swati, Department of Physics, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. In the last session, we had discussed about the introduction part of motion in a plane. What is motion in a plane? Why it is called so? So, any body which is moving in two dimensions, will call it as motion of object in plane. So, we have discussed about the concepts called scalars, which means any physical quantity which has only magnitude, we call it as scalars, and vectors, which means a physical quantity which has both magnitude and the direction, we'll call them as vectors. And also we had discussed about the representation of vectors, what are the different types such as zero vector or null vector, coplanar vector, concurrent vector, equal vectors, parallel vectors, and so on. And also we had discussed about operation of vectors such as vector addition. So in vector addition we had learned about the law of vector addition, that is triangular law of vector addition and parallelogram of vector addition. Triangular law and parallelogram law helps us in understanding how to find the resultant of two vectors by different statements. So in the last session we have seen what is the expression for resultant of two vectors, two concurrent vectors, that is root of p square plus q square plus 2pq cos theta, or it can also be written as r equals root of, suppose if the vectors are a and b, then it can be written as a square plus b square plus 2ab cos theta. So in today's session, let us learn how this is derived, how to write the expression of resultant of two vectors. So we are now going to derive the expression for magnitude and direction of resultant of two concurrent vectors. The magnitude is given by the formula r equals root of p square plus q square plus 2pq cos theta, and direction is given by theta is equal to tan inverse of q sin theta divided by p plus q cos theta. So this is the expression for direction and this is the expression for magnitude. So let us now derive the expression for magnitude and direction of resultant of two concurrent vectors. So for that, first we have to write the diagram. Here we have considered a parallelogram law of vector addition. Here P is a one vector and Q is the another vector. We can also write Q here. And the resultant of these vectors is given by the diagonal, as we have studied in the parallelogram law of vector addition. So the resultant is given by vector r, which is equivalent to sum of vector p and q. So let p and q are two vectors acting at a point O, making an angle theta. Look at this, p and q are acting at a point O, they are making an angle theta. They are represented by OA and OB. The diagonal of the parallelogram, that is OC. Look at this, the diagonal of the parallelogram OC represents the resultant of these two vectors. The resultant of vector P and vector Q. So now let us draw CD, which is perpendicular to the extended line OA. So here we have extended the line OA till D. So let us now write the perpendicular CD to the extended line of OA. In the right angle triangle ODC. Look at this carefully. In the right angle triangle OD and C, now we have to define certain terms to get the desired expression. So from this triangle, you can see here we are applying a Pythagoras theorem. What is Pythagoras theorem? The square of the hypotenuse is equal to sum of the square of other two sides. Here hypotenuse is OC. So OC square. Squares of other two sides means what are the other two sides? OD and CD. So we have to square that and we have to add it, which gets OD square plus CD square. So I hope this expression is clear to everybody. This is from Pythagoras theorem. So from Pythagoras theorem, the sum of squares of other two sides is equal to the square of hypotenuse, from which we can write it as OC square is equal to OD square plus CD square. Now see here, we have replaced this OD square with OA plus AD square. What does it mean? How can we write that? See, this OD can be written as OA plus AD. It is nothing but OD. So for the simplification purpose, we are splitting and writing OD square is OA plus AD the whole square plus CD square as it is I am writing. So now it is of the form A plus B the whole square. So what is the formula of A plus B the whole square? It is A square plus B square plus 2AB. Or we can also write it as A square plus 2AB plus B square. Now we have OA plus AD the whole square. So OA is nothing but A, AD is nothing but B the whole square. So what we can write? So here according to this expression, OA is nothing but A and AD we are considering as B. So A plus B the whole square is A square plus 2AB plus B square. So in the place of A, we have to write OA. In the place of B, it is AD. So according to that formula, it is OA square, that is A square plus 2 into OA, that is 2AB. B is nothing but AD plus AD square, which means it is of the form A square plus 2AB plus B square and plus CD square as it is I am writing. So next we have OA square plus 2OA into this AD can be written as, look at this diagram carefully, we have a triangle ADC. So now for simplification purpose, this AD can be written in terms of AC cos theta. How do we get AC cos theta? Let us now consider this triangle ADC. So from this we can write cos theta is equal to adjacent divided by hypotenuse. So in this triangle, which is the adjacent side, it is AD divided by hypotenuse is AC. So we have cos theta is equal to AD divided by AC. We want AD term. So retaining AD, we can write this gets multiplied here AC cos theta. So we can write in the place of AD, we can write AC cos theta plus CA square. So where did the CA square come from? Look at this. We have AD square plus CD square. So look at the diagram. AD square plus CD square, which is equal to hypotenuse, square of the hypotenuse. AD square, side, one side square plus the other side square. Sum of the squares of two sides, which is equal to square of hypotenuse, which is nothing but the Pythagoras theorem. So from that we can write AD square plus CD square is equal to AC square. So it can be written as CA square. So after this expression, we need to replace these terms with the representations. So now we have R square is equal to OA square is nothing but, see, OA is denoted by P. So it is P square plus CA square is nothing but Q. So P square plus Q square plus in the place of 2, as it is 2, I am retaining OA is nothing but P again and AC is nothing but Q. So 2PQ cos theta as it is writing. We just need the expression for resultant of magnitude. So R we just required. So R is equal to square root of these values, that is P square plus Q square plus 2PQ cos theta is the expression for magnitude of resultant of two vectors. Now let us derive the expression for direction. You can see here alpha is the angle made by R with P. Considering right angle triangle, so right angle triangle, How to define tan theta? So generally tan theta is defined as opposite divided by adjacent. So now our angle is alpha. Alpha is the angle made by resultant with P. So tan alpha is equal to, what is opposite side in the right angle triangle? This right angle triangle, opposite side is CD. So it is CD divided by OD. But OD can be written as OA plus AD. So here I am writing the same, it is OA plus AD. I have already shown you from this triangle, consider triangle A, D and C. How to define sin theta? Sin theta is opposite divided by hypotenuse. What is opposite? It is CD divided by hypotenuse is AC. So we have sin theta here. But what do we have here in the numerator? CD. So for simplification purpose, we can write CD is equal to AC gets multiplied with sin theta. So it is AC sin theta. In the place of CD, I am writing AC sin theta divided by OA plus, in the place of AD, we will get AC cos theta. I have already shown you in the previous slide. Now let us replace these values by the respective terms. So what is AC? According to diagram, AC is nothing but Q. So in the place of AC, we get Q. So it is, this expression will be Q sin theta divided by OA is nothing but P. So P plus AC cos theta. AC is again Q. So we get Q sin theta divided by P plus Q cos theta. So it is the value of tan alpha. So tan alpha is Q sin theta divided by P plus Q cos theta. But we need only alpha. So it can be written as, this comes to other side by transposing. So tan inverse of Q sin theta divided by P plus Q cos theta is the expression for direction of resultant of two concurrent vectors. Let us solve one example now for finding the magnitude and direction. So it is given that V is equal to 4i cap plus 4j cap, where I cap and j cap are the unit vectors. Find the magnitude and direction of velocity vector. We know how to find the magnitude by our formula, that is r is equal to root of a square plus b square plus 2ab cos theta. In this question, our a is 4 and b is also 4. So the given questions are with the unit vectors and the value of theta is 90 degree. So r is equal to root of a square plus b square plus 2ab cos theta. So the cos 90 value is 0. So if this is 0, the entire term becomes 0 and we get v is equal to root of a square plus b square. Why it is written as v? Because we are finding the velocity vector, resultant of velocity of two concurrent vectors. So v is equal to root of a square plus b square. So what is a, as I told you, it is 4 and b is also 4. So v equals root of a square. So it is 4 square plus b square. Again 4 square, 4 into 4, 16 plus 16. So you'll get root of 16 plus 16, which is nothing but root of 32. So square root of 32 value is 5.65. Since it is a velocity, the unit is meter per second. This is the magnitude. Let us now find the direction. So direction can be calculated by the formula alpha is equal to tan inverse of b sin theta divided by a plus b cos theta. Suppose if you take this value with the notations p and q, then this formula will be tan inverse of q sin theta divided by p plus q cos theta. It depends on how do we take the data. So it is b, I have taken it as a and b and hence I am writing the expression as b sin theta divided by a plus b cos theta. So tan inverse of b is nothing but 4 sin 90 divided by 4 plus 4, that is a and b value are 4 and 4 respectively. So 4 plus 4 cos 90. What is the value of sin 90? It is 1. So this expression will become 4 into sin 90 value is 1 divided by 4 plus cos 90 value is 0. 0 into 4 is 0 again. So this will be 0 and hence we will get 4 divided by 4 and the value is 1. So tan inverse of 1, the value of tan inverse of 1 is 45 degree. So this is the direction of the given vector. So far we have discussed about the vector operation, that is addition of two vectors. So let us now move on to the second operation, that is subtraction. How to subtract a vector? So subtraction of a vector b, suppose let us take a two vectors a and vector b. So now subtraction of vector b from vector a is defined as addition of minus vector b to a vector a, which means a plus minus vector b is equal to vector a minus vector b. This is very simple to understand the definition. So to subtract b from a, what we are supposed to do? We need to add the negative of b to a. So that is how the vector subtraction to be done. Say for example, vector a minus vector b. To perform this operation, which means to subtract b from a, we have to add the negative of vector b, which will be our resultant. So you can take this simple example. We know 3 plus 7 is equal to 10. So to subtract 3 from 10, what I have to do? I have to add the negative of 3 to 10, which will get me 7, the value 7. That is how we need to subtract the values in case of vector subtraction. So next we have operation 3, that is multiplication of vectors. Vectors can be added, vectors can be subtracted, as well as we can multiply the vectors. How to do this multiplication operation? Multiplication of a vector with a real number gives a vector. What does it mean? How to multiply a vector with a real number? Say for example, if vector a is multiplied by 3, then what is the resultant? The resultant vector is 3 into vector a. 3 times the vector a. Similarly, if vector a is multiplied by minus 2, then the resultant value will be minus 2 of vector a, which has direction, but it is opposite to that of a since it has got the negative value. Here negative sign indicates that the direction is opposite. Next, example for vector multiplied by a scalar. We know what is a scalar? The value, the quantity which has only the magnitude. For example, mass. For example, length. We know what is a vector? It has both magnitude and direction. For example, acceleration. For example, force, weight. Now, what happens if a scalar and vector gets multiplied? Can we give some example? Yes, of course. So, force is nothing but the formula to find the force is F is equal to m into a. But what is m? M is a mass, which is a scalar. A is acceleration, which is a vector quantity. Since it is a vector, it is denoted by a symbol, arrow mark on top of the magnitude. So force is also a vector, acceleration is also a vector. So we can give an example for a scalar which gets multiplied with a vector, F is equal to m into a. What about linear momentum? Linear momentum is denoted by P. P is equal to mv is a very well known formula for all of us, where v is a velocity, which is a vector quantity, m is a scalar quantity. So this is the best example to understand vector multiplied by a scalar. So next let us understand resolution of vectors. So far we have discussed the meaning of vector, representation of vector, types of vector and vector operations such as addition, multiplication, subtraction. Let us now move on to resolution of vectors. What is the meaning of resolution? The name itself says resolving, splitting. So the resolution of vector means splitting up of a vector. Yes, the process of splitting up of a vector into two or more components such that the component vectors combined to produce the same effect as it is produced by the given vector. Which means if we split a given vector into number of components and if we combine all these components, the effect produced by this combination will give the same effect as the vector was giving before it gets splitted up. So resolution means basically the process of splitting up of a vector into number of components. If a vector is resolved into two vectors which are mutually perpendicular, then these vectors are called as rectangular components of the given vector. vector. If any vector is splitted up or resolved into a perpendicular components, then we will call those components as rectangular components of a given vector. Say for example, here vector A is splitted up into two vectors by rectangular components such as x-axis and y. Here in the example, vector A is splitted into two vectors, A along x-axis, vector A along y-axis, and hence it is written as A with subscript x with arrow mark, which means vector A along x-axis and vector A along y-axis, and it can be written as ax into I cap plus ay into j cap since it is a unit vector. So I cap and j cap represents the unit vectors along x component and y component. So ax and ay are the components along x and y axis of vector A, because this is the vector which is getting splitted up along x axis and y axis. So the magnitude of ax is nothing but a cos theta along x-axis. So the component is resolved into two parts, along x-axis, along y-axis. So along x-axis the magnitude is represented as a cos theta, along y-axis the magnitude is represented by a sin theta. Now how to come for a conclusion? It is a cos theta and a sin theta. For that, let us derive the expression. So our next concept is derive the two mutually perpendicular component of a vector. So to derive this, first what we have to do, we have to split a given vector into two components. If R is a vector which makes an angle with the x-axis, you can see here, so these two, R is a vector which is resolved into two components. Along x-axis I'll call it as Rx, along y-axis I'll call it as Ry. As shown in the figure, if R is a vector which makes an angle along x-axis, as shown in the figure, draw a perpendicular from R to x-axis and y-axis respectively. Let us now draw a perpendicular to x-axis and y-axis respectively. I think the diagram is very much clear to everybody. Now, OQ, vector OQ is nothing but vector RY, which means the side OQ represents Ry. The component of R along y-axis is denoted by R subscript y. Similarly, OP is nothing but Rx, which means the component of R along x-axis, it is denoted by R subscript x. So OP is equal to Rx. Be the mutually perpendicular components of R. As I told you, R is split into two components. Along x-axis it is Rx, along y-axis it is Ry. So x-axis I have taken OP and y-axis OQ. So OP equals Ry, OQ is Rx. Now, we know the resultant vector is nothing but sum of the two components. Here, the resultant is R, which is equal to sum of two components, that is Rx plus Ry. From triangle OAP, take this triangle now, consider this triangle OAP. What is sin theta? Sin theta is nothing but opposite divided by hypotenuse. So, what is opposite? It is AP and hypotenuse is OA. So, sin theta is equal to AP divided by OA. But what is AP? AP is nothing but RY. Since these two are opposite sides, it is nothing but RY and this side will be RX. So, in the place of AP, we can write RY, OA as it is I am writing. Or we can write it as, in the place of OA, so what is OA? OA is nothing but R. So we can write it as, this can be written as Ry divided by R, which is equal to sin theta. So this can be written as Ry is equal to R into sin theta, or vector Ry is equal to R into sin theta into j cap. Since it is along y axis, I have taken it as j cap. Along x axis, we will use I cap for representing the unit vector. Similarly, now let us take this triangle once again. Let us now define cos theta. How to define cos theta? It is adjacent divided by hypotenuse. From this triangle, what is adjacent? It is OP and hypotenuse is OA. But what is OP? OP is RX. What is OA? OA is R. So we get cos theta is equal to RX divided by R. Or we can write it as Rx is equal to R into cos theta. So it is Rx is equal to R into cos theta. Or in the form of vector if you want to represent, so vector Rx is equal to R cos theta into I cap. Don't forget, vector representation must be with the unit vector. So it is r cos theta into I cap along x axis, r sin theta into j cap along y axis. Therefore, what are the mutual perpendicular components of r? They are r cos theta and r sin theta. So from that we can conclude that the magnitude Ax is resolved, or it is splitted up into A cos theta and the other component is A sin theta. For this we have proved the derivation. So from today's session we have learnt the expression for the magnitude of resultant of concurrent vectors and the expression for direction of resultant of two concurrent vectors, and even we have discussed about the operation 2, that is vector subtraction, vector multiplication and the resolution of vectors. How can we write the expression for a vector when it gets splitted up by two axes, splitted up into two components? So these expressions and the derivations are very much important. In the next upcoming sessions, I'll come up with some more interesting concepts. Until then, take care all of you. Thank you.